Good afternoon, everyone. We are ReelDeal, also known as Group 9, and for our wearable device, we went a little off the beaten path. We designed ReelDeal, a fishing belt with safety at the forefront. Fishing belts exist to provide more leverage to the fishermen when reeling in their big catch. However, strapping a fishing rod to your body in this way can be incredibly dangerous, as many of the coveted deep sea fish can weigh over twice as much as an adult man and could easily drag you underwater. With this in mind, we designed the first ever built-in safety release on a fishing belt to allow the user to quickly and effortlessly sever their line, losing their catch, but not their life. ReelDeal consists of a robust base plate to help rest against the user's thighs and provide plenty of leverage while dispersing the pressure across the entirety of the plate. The rod is easily inserted into the cannon-like rod holder, which is only allowed one rotational degree of freedom. The fishing line is fed from the reel, around the loops of our cutting mechanism, and back to the rod. While not pictured, there will be a razor blade inserted into the bottom of the handle, which will instantly cut through a taut fishing line like a hot knife through butter.
Here we display some examples of using parametric curves within SOLIDWORKS. We wanted to attempt and show the curves themselves with a brief explanation, so going from left to right, we first had the utility loop. This simple part used a hand-calculated Bezier curve. It is hard to see, but the individual points that create the curve profile are shown in this image. This part also uses a parametric circle for the faces. Next, at the top, we have the base plate. This design uses varying degrees of parametric Bezier curves to create the unique profile. It also uses a concentric parametric circle for the central socket joint. And lastly, we have the rod insert. This component uses a parametric semicircle for the shape and then a parametric Bezier curve for the extruded profile. Now, we'll quickly go through a few engineering drawing examples, each of these using the third angle projection system and SOLIDWORKS software. To start, we have the bottom half of the handle for our cutting mechanism assembly. The important aspects of this drawing are the hinges used to lock the handle into place and the insert for a sharp edge that would be used to cut the fishing line. We were unsure of UTD policy for creating a sharp edge, or if the printer would be able to create a sharp thin profile, thus we left an insert there to add a real one if needed. Next, we have a simple one, the utility loop. This just shows the overall size of the loop, the radii of the Bezier curves, and the diameter of each face. And lastly, we have half of our cutting assembly, as it was made to be assembled once printed using a unique locking design. Here, each of the lengths and heights can be seen, noting that none are greater than half an inch other than the overall assembly height. The unique features include the connecting pegs and the handle hole at the top. The pegs are meant not only to lock the two halves together, but also as a mount to wrap the fishing line around in order to make it taut. This would make it easier for the blade to cut in case of emergencies.
A very good afternoon to one and all present. I'm Yashardhan and I'll be demonstrating the results of a few analyses that we carried out to determine whether our design is safe from failure. The image on the left shows the assembly and the resultant forces acting on the ball socket joint, which will be the area of maximum fatigue and contact. And the ABS plastic does perform fairly well as it limits the maximum stresses to about half of its ultimate strength. Even on the figure to the right, we see that the spherical ends are most susceptible to failure as opposed to the rest of the design. A 15 kN force is applied to test, and an internal force is applied to contribute for the user motion as well as any forces applied from the fish. The most deformation, as we can see on this slide, is observed in areas of curvature, which too is in the scale of barely a few millimeters. We have provided for safe clearance limits so that the parts do not collide for the majority of its usage, and the functional mechanisms such as logbox do undergo negligible changes, as we can see, which are in millimeters, and the rod holder too does not show much deformation, and we can conclude that the design is completely safe.
In terms of things we learned and noticed during the creation of ReelDeal, one of the challenges we ran into was fitting the rod socket into the base plate. We had to make sure that we created a connection that would allow for the socket to have a specific angular range of motion on one axis while keeping the socket fixed in the other two axes. In the beginning, designing the base plate itself also presented its own challenges due to its unique and multifaceted shape. In terms of the simulations we performed, due to material removal, the test results may have been inaccurate. An improvement we could definitely make to ReelDeal is increasing the utility appeal to the consumer so that they can have more reasons to obtain it. Some of the things we learned while working on this project include the overall design process for making a product, different design philosophies and how to take them into account, such as designing for assembly, for safety, etc., and the overall usefulness of parametric curves when it comes to modeling. Thank you for listening to our presentation. We hope you guys enjoyed, and now we're going to open up the floor to questions.